This question is asking about the intervals on which the function is concave up and the intervals on which the function is concave down and the inflection point from the graph. How do we determine that? The first step to determining the intervals on which the function is concave up or down is to determine the inflection point. The inflection point is basically a point where the function changes behavior from concave up to concave down or vice versa. So to make sure that you understand what I'm talking about, this is basically right here is the inflection point. So to answer this question, I will say there is an inflection point at 1 and 4. I know that because this part of the function is concave up and starts to change to concave down on the other part of the function, that one. And that's why this point is an inflection point. So here you can see the line clearly. That is the inflection point. So that is the first thing I need to do. So the inflection point is 1 and 4. It happens at 1 and 4. Next, I will find where the function exactly is concave up and where the function is concave down. And I highlighted the part of the function that is concave up and the part of the function that is concave down. To determine the intervals, I know the function here is coming from negative infinity and it stops at x is equal to 1. So basically the first interval where the function is concave up starts from negative infinity and it stops at the value of x is equal to 1. And where the function is concave down, I know if I am scanning the graph from left to right, then I know that the function starts to get concave up from the point when x is equal to 1. And it continues to infinity. So from 1 to infinity, the function is concave down. So here I would say concave up on negative infinity and 1, and concave down on 1 positive infinity, and that should solve that question. So I hope this helped you understand how to answer this type of question, and I will see you in a different video.